Hi guys, Mrs. Delisin here. Welcome to another lesson of Algebra 2. Today's lesson is we will be learning how to determine the horizontal asymptote of a rational function. Let me start by reviewing what vertical asymptote is. So hopefully before watching this video, you've completed vertical asymptotes already. So here, we've learned in the previous lesson that this line in here is called our vertical asymptote. I know it's going across the y-axis, but in this case, we call this our vertical asymptote. Today, we are going to be learning about this line here, and this is called our horizontal asymptote. Just like the vertical asymptotes can be here sometimes, it can be here sometimes. The horizontal asymptote also is not just always in here. Sometimes it's up here or sometimes it's below here. Okay? In this lesson, we will examine how to determine horizontal asymptotes. The graphs of the corresponding rational functions will be given in each example, though we will not deal with graphing until a later lesson. Okay, if you have your packet printed, I would like you to highlight this whole entire thing. The y value of each horizontal asymptote may serve as a range restriction. Not a domain restriction, but a range restriction. Unlike vertical asymptotes, though, however, it is possible for the graph of a rational function to cross a horizontal asymptote. If you remember when I was talking about vertical asymptote, you can never cross it, you can never touch it. But in some cases, the horizontal asymptote can be crossed by the rational function in special cases only. So later, we are going to see what cases are those, right? When we start graphing the rational function. Okay. Unlike the vertical asymptotes where it depends on what denominators or what factors you have in the denominators, like say if you have, for the vertical asymptote, if you have 1 over x minus 3, then your vertical asymptote is x is equal to 3, right? So it depends really on what your denominator is. But the horizontal asymptote depends on 3 rules, okay? You have 3 different rules. The first rule is, let's say here, whenever I say n, I meant numerator. Whenever I say d, I meant denominator. Let n represent the degree. Degree means the largest exponent of the numerator. Let d represent the degree or the largest exponent of the denominator. The first rule, or technically property, if n is less than d, right? If the numerator or the largest exponent in the numerator is lower or is less than the largest exponent of the denominator, then our horizontal asymptote will be y equals 0. And I'm going to use HA to represent horizontal asymptote. So our horizontal asymptote is y equals 0 when n is less than d. Okay, moving on. If n is equal to d, that means the largest exponent on the top is the same as the largest exponent on the top. What you will be doing is you're going to divide the leading coefficient. So this is y equals coefficient on the top divided by the coefficient on the bottom. And that would be your horizontal asymptote. Okay, moving on. There are also other cases where n is greater than d. When n is greater than d, what does that mean? The largest exponent in the numerator is greater than the largest exponent on the denominator. When that happens, we don't have a horizontal asymptote. We have none. So, example number 4. Let us determine the horizontal asymptote of the graph 3x plus 6 and x squared plus 4x plus 3. Let us get the highest exponent in the numerator first. So here we have a 3x. So that is x to the power of 1. So our numerator has 1 as the largest exponent. Our denominator has 2 as the largest exponent, or the degree of the quadratic, right? 2 in the denominator. So n is less than d. And because n is less than d, we are going with our first one, which says when n is less than d, when the numerator is less than the denominator, then the horizontal asymptote will be y equals 0. So in this case, our HA is y equals 0. Okay, moving on. So if I'm going to draw that, because remember, I always draw it even the previous vertical asymptote. That means we have a horizontal line at y equals 0. Okay, moving on. For example, number 5. Oh, by the way, that's the example there. For example, number 5, we are going to compare the exponent on the numerator is 3. The exponent on the denominator, you have a 2. So in this case, n is greater than d. The exponent in the numerator is greater than d. When that happens, which rule is that? When that happens, we will say no horizontal asymptote. So in example number 5, we will say no horizontal asymptote. Okay, moving on. Example number 1. We have here 3x to the power of 1. So I'm going to circle that, and I'm going to circle that. So the numerator has a largest exponent of 1. The denominator has a largest exponent of 2. So in this case, n is less than d. Whenever that happens, let's go back. When n is less than d, our horizontal asymptote would be y is equal to 0. Okay, so we are going to do y equals 0 for our horizontal asymptote. Okay, and it's also here, y is equal to 0. Moving on, number 2. What if, so let's circle this. This is the largest exponent. So the largest exponent on the top is 2. The largest exponent in the denominator is also 2. So n is equal to d. So when that happens, that the numerator has an equal exponent, largest exponent in the denominator, let's go to the second rule. When that happens, you are going to divide the two coefficient. So let us divide the two coefficient. We have the coefficient of 3x squared is going to be 3. So it's going to be y equals 3 over the x squared has a 1. So my horizontal asymptote is y is equal to 3. And it's right here also. Okay, moving on, example number 3. Let me circle. This is the highest on the top, and this is the highest in the bottom, in the denominator. In the numerator, my largest exponent is a 3. In the denominator, the largest exponent is a 2. So in this case, n is greater than d. When the numerator has a greater or larger exponent than the denominator, we will say that we have none. We have no horizontal asymptote. The word none would suffice. That's perfect. Okay, example number 4. There you go. So I have the rules in here too, just in case. I'm going to circle 3x. I'm going to circle x squared. So the largest exponent on the top is 1. The largest exponent in the denominator is 2. So n is less than the denominator. When that happens, I'm following the first rule that our horizontal asymptote will be y equals 0. So HA is y equals 0. Moving on. Example number 5. My n has a largest exponent of 3. My denominator has a largest exponent of 2. So n is, I think we did this one already, right? I think I copied the pages accidentally again. Okay, so mine as well. So n is greater than t, so that means that we have none. Okay, I think let's go here. Okay, we did everything. I forgot that I copied the next page, so we have our rules right at the top of these examples. Okay, so we have 2x minus 3 over x plus 4. Let us get our horizontal asymptote. I'm going to circle this because this is the winner on the top. This is the winner on the bottom. The numerator has a largest exponent of 1. The denominator has also a largest exponent of 1. So when the denominator and the numerator has an equal, right? If they are equal, you are going to divide the coefficient. So the coefficient of 2x is 2. The coefficient of x is 1. So y is equal to 2. So our HA is y equals to 2. Moving on, number 2. I did say n is equal to d. Okay, next. I'm going to circle 3x. I'm going to circle x squared. The largest exponent in the numerator is 1. The largest exponent in the denominator is 2. So n is less than d. Whenever that happens, our horizontal asymptote is y is equal to 0. Okay, moving on. I'm going to circle x squared. I'm going to circle x. The largest exponent in the numerator is 2. The largest exponent in the denominator is 1. So n is greater than d. Whenever that happens, we do not have a horizontal asymptote. Okay, moving on. We have negative x squared as the winner on the top, 3x squared as the winner in the bottom. So our n has a 2, has a largest exponent of 2. Our denominator also has the largest exponent of 2. So whenever n is equal to d, we are going to divide the coefficient of the numerator and the coefficient of the denominator. So this is negative 1 and positive 3. So this is negative 1/3. So our horizontal asymptote is y equals negative 1/3. I'm going to draw how it looks like, and in your homework, I would also require you to just sketch me the horizontal asymptote so that when we get to the graphing part of the rational function, we are not going to have a hard time because we already know where everything is coming from. Okay, let's try to do this. My horizontal asymptote is a y2. So I have a horizontal asymptote in there. And then here is a 0. So the x-axis itself is our horizontal asymptote. This one is none, so I don't have to draw anything. Here is a negative 1/3. So it's a horizontal line over here. All right, there you have it. I hope that you are able to do your homework about horizontal asymptotes. Thank you, everyone. I'll see you guys on the next video. Bye.